Okay, so this, I realized I didn't have anything to talk about the lymphatic system. And so in this brief video, you see three basic models that that we use to represent. Now, we also have slides, and I think the slides are already loaded in your modules. And the slides will be of the spleen and of the thymus and the lymph nodes. I also found some tonsil slides, which might be good for us to look at as well in class. So I'll have to add that. Otherwise, the lymphatic system is really spread throughout the body. And the reason it is, so we have this board model that actually is built to emphasize the vessels and the nodes, okay? And then I brought in the torso, and because the brown man's being used for the practical right now, to show, and they, in this model, they've actually shown the nodes in this lovely green coloration to stand out, and then the vessels are obvious as well here. And arguably, the model wasn't made to show a lot of specificity, but you can certainly see, like I said, if you look up at the top here, you'd see basically the superficial, whoops, sorry, you can't look at the top there, right? If you look up at the top there, you see the basic superficial cervical nodes and vessels. It doesn't show the ducts like the brown torso does, and this one does. It's not really made to represent the trunks, because it happens that we start with capillaries in the lymph system, and they lead into vessels, which capillaries you can't see, but vessels you could see. And then the vessels move into nodes, which is just a bunch of, it's encapsulated, so it's an organ, but a bunch of lymphocytes and macrophages together, right? And then vessels leave the nodes, and eventually the vessels converge into trunks, which are slightly larger, and the trunks then end in two ducts. And the ducts join, you can see this on this model up here, they join the vascular system, the venous system, right as the subclavian and the jugular veins come together. There's a duct on each side, right? And then we're dumping the fluid all back into circulation. So we've got a couple of issues that we have to cover here in the lymphatic system. So we start by understanding what it does, okay? So as I was talking about collecting fluid, it's going to recover some of the fluids that stayed behind in the capillaries when exchange occurred. So it may not have been apparent to you numerically, but there's typically there is more hydrostatic pressure that pushes out, right, than osmotic pressure that keeps it in on the arterial end, and that's why the bulk flow is outwards, and that's great. We deliver oxygen, we deliver nutrients to the cells of the body, all right? And then the blood continues to move through the capillary, the hydrostatic pressure dropping, so by the time we get to the venular end, the hydrostatic pressure is actually lower than the osmotic, and so the bulk flow is back into the capillary. But the net pressure difference in and out is not equal. So there's actually the net pressure that pushes out is a little higher overall than that pulls it back. And as a result, there is a little bit of fluid that stays behind. And again, this would be plasma, when we talk about fluid, that becomes tissue fluid. Stays behind, right, every time that exchange occurs. Well, how many exchanges would you do before you literally ran out of fluid? So there has to be some way to recover, and that's one of the roles of the lymphatic system. So it starts as capillaries. You can't see that on any of these boards, right? Oh, well, the exception of, forgive me, actually here, that's a lymphatic capillary. So let me get out of the light here, take this swivel over, right, and say this is a lymphatic, no, sorry, swivel's not behaving, right, over here, not me, I don't have the sensor, right? That is a lymphatic capillary. It's called lectile, and they're found within the villi in the small intestine. This is a model of the small intestine, right? So this is a model of a microscopic feature. These other two models, the trunk and the board, are gross anatomy, right? So that's microanatomy, and so you do see a lymph capillary here, and it is leading right away from the blood capillaries, and it's going to eventually become a vessel here in a short period of time, right? And so it's going to end up being in this area, right? So it's probably going to drain the fluid from this, right, is probably going to eventually drain into these mesenteric nodes and pass into these vessels and be dumped into this broad tube that you can't quite see from this angle, but this widening in the tube that's called the cisternae chylae. So, but that's again, so that's showing a capillary. The rest of these don't show capillaries, but that's how the lymphatic system starts. It starts as capillaries, it moves into, it becomes larger and larger, so similar to the vascular system, but then different. The fluid will move through these nodes. All right. So when I look at these nodes again, what I want to think about is filtration. All right, so these are filtering. Come over here. Right? These will be filtering that fluid. Now, why is that important? Well, think about it. This fluid, you know, the blood is a passive river, basically, that allows anything that's small enough and can pass through a cell membrane to enter, and it's in the body. So now we have to have a way to actually determine what should stay and what to do with the things that are there. And so these nodes are very important, and there's hundreds of these. They're in the line of the vessel. And so you would see this fluid being collected, fluid that was part of the blood, collected into these tubes, and these tubes then would come to this structure, a lymph node. And in the lymph node would be a whole lot of lymphocytes and macrophages. And so we would have a chance for encountering, right, specific antigens that might be harmful, right? So you'll notice here that the nodes are actually very strategically located. They're located really within very much within the axial skeleton, the areas where we have these cavities, the cavities that need to remain sterile. It's not that your arms and legs don't need to stay sterile, they do, but they don't have vital organs in them. So having an infection or contamination in them is not nearly as life-threatening as it would be in this area. So you see that represented. You see lots and lots, and even on this model that isn't really made to show nodes specifically, you see that it's really as that fluid is collected and comes into the abdominal, pelvic cavity and the thoracic cavity, it's going to encounter a whole lot of nodes, and this will help in one of the other functions of the lymphatic system, which is defense, right? And then the third function, so again, recovering fluid, defending you, and then the third function is really the absorption and transport of lipids or fats. And that's what you're specifically seeing happening over here, right, in this small intestine model. Sorry, there you go, right? And so this is, again, a lymphatic capillary that's specifically called a lacteal, positioned here with the blood capillaries. So a lot of the food's out here, right? And what happens is you're going to discover in chapter 17, that we're not there yet, right, that the nutrients that are coming in, proteins, carbohydrates, lipids, nucleic acids, vitamins, minerals, right, that are coming in, all have to be broken down chemically to the smallest possible size by the digestive system. And then they will be absorbed across these, simple columnar cells passing through their membranes. Well, fats they're very large, all right, and it has to do with the fact that because they're predominantly nonpolar, they don't stay in solution, right, and these are solutions. And so they have to be reconfigured chemically into these structures that we collectively call lipoproteins. And so LDL, HDL are examples of that. In the beginning, they're actually called chylomicrons that we'll discover in chapter 17. And these chylomicrons, they are my cells out here, they become chylomicrons in here, in these cells, and they don't get into the capillaries, right? They're very large, and they're decorated with all these, polar molecules, proteins basically. That's what they're lipoproteins. And so they are actually, they go into the lymphatic system first. Now remember that the lymphatic system collecting all this is eventually going to drain back into the blood. So no worries, you're going to get your fat. I know you're probably thinking, wow, that's a great weight loss, but no, it's right, you're going to get your fat. It's going to come in through these tubes when these tubes join these tubes. All right, because we need that fluid back, and yes, we do. We need fats. They have things that we want in them. All right. So another example on this model of it's not a lymph node, but it's a collection, like the tonsils are, a collection of the lymphocytes and macrophages, and it's here in the small intestine. It's in the submucosal wall. Typically, the submucosal is a layer we're going to learn about in chapter 17. And it's just a whole bunch there together. So it's an opportunity for encounter, because as we get to the last region of the small intestine called the ileum, we basically have removed all the nutrients and things we want, and it's now in our body. And so what's left out here is literally a bunch of crap, right? I mean, there's things we still want, but it's a lot of, you still have bacteria, you still have all this concentrated stuff that we don't necessarily want to come into the body, all right? And if it does happen to pass through this, right, simple one cell layer thick here, then we have strategically located these lymphocytes that are going to recognize antigens, and they're going to defend you. And then we're going to have macrophages that can clean up. So this, right, trying to show you the dark nuclei in the cytoplasm here, of the lymphocytes that are here, is called a Peyer's patch or Peyer's patch. It's capital P-E-Y-E-R apostrophe S. And it really is a lymphatic nodule, like the tonsils are, right? So moving into these two models, over here, what we have, over here, right? What we have, again, are the vessels shown very clearly. Predominantly vessels are the lines, and moving the lymph fluid, and then passing into nodes, all right? And we're going to call these afferent as they bring it to a node, and efferent as they leave, they go away from the nodes, but that's what they are, right? So the nodes are named basically regionally, right? So these are your inguinal here, right, as the leg comes into the trunk, all right? You have mesenteric, right? You have hepatic up here. You have gastric here, right? You have axillary here, and cervical up here, deep cervical here, right? Occipital here, median cubital here, okay? Parotid up here, submandibular, right? Submental, because the chin's a mental region, right? So they're pretty much named for their location. And if you ever get lost, there's actually a key right here, right? Also on here, you do see what we call the right, there's just two ducts, and they're the largest tubes that bring in all the lymph fluid from the body. So the right lymphatic duct pretty much drains the right head and thoracic region arm. It brings back all the fluid that was left behind from this area of the body, right? And that's the right lymphatic duct, and it's joining here as the subclavian and jugular come together. The other duct is called the thoracic duct, and it actually starts, yes, in the thoracic cavity here, and you see it widening, and then it drains right here, again, as the left jugular and left subclavian come together. And this pretty much drains the majority of the body. Both legs and left arm, left side of the head, all those fluids are going to come in here. And so we're returning everything back to the cardiovascular system. All right? There are two, according to the key, there are two trunks. So these are slightly larger than the vessels, but not as big as the ducts on here. And there is a jugular trunk here, following along with the jugular vein on the left side. And right here's a subclavian trunk right here. Okay, so, but otherwise, it's pretty much the names reflect the regions. As we look at pink man or brown man, as we affectionately call them, you see areas like here, again, this is probably, you're in the inguinal here. We don't see the axillary here. We don't see ducts here. We definitely see the cervical up here, right, and some submandibular up here, parotid here. But otherwise, it's not really made to specifically show you a lot of lymphatic, and that's why we ended up buying this model, right? So you're not going to see the thymus on, so the nodes are pretty much represented on the torsos or on these boards. Thymus is not going to be on any model. And then the spleen, of course, it's shown right here. It's always just behind, just kind of posterior and lateral to the stomach. So here's a bit of the spleen here. Of course, it's here too. It's a very bloody, flattened organ, just lateral to the kidneys, because the stomach's been moved here. So it typically, we see the spleen on a number of different models to think about that too. So that pretty much covers what we're going to want to know as far as the lymphatic system. So I hope this helps you. I hope I haven't made any mistakes.